Hi all. Today we will discuss what is learning rule in artificial neural network. So, a learning rule is a mathematical algorithm used in artificial neural networks to adjust the network's weights and biases, which improves its performance by minimizing the error between its predicted and desired outputs. Learning in ANN involves adjusting the weights of the connections between neurons to improve performance on a given task. This adjustment is governed by learning rules, which define how weights are updated based on input data, output, and the errors. So basically, we can say or we can define learning rule in simple words as a learning rule is a guideline that teaches the neural network how to learn. So there are basically many different types of learning rules present in ANN. So we can move forward and learn each one of them. Yeah, the first one is Hebbian learning rule. This rule is based on the biological concept that neurons that fire together wire together. Hebbian learning rule is an unsupervised learning algorithm used in neural networks to adjust the weights between nodes. It is based on the principle that the connection strength between two neurons should change depending on their activity patterns. So we can summarize this as follows. When two neighboring neurons operate in the same phase at the same time, the weight between them increases. If the neurons operate in the opposite phases, the weight decreases. When there is no signal correlation between the neurons, the weight remains unchanged. We can discuss this using a simple example, that is how a human learns to ride a bicycle. A cycle, simply. Can say this one. Okay. Sorry for my handwriting and all. Okay. So, first of all, when you learn to ride a bicycle or cycle, your eyes, your hands, legs, and balance system all send signals at the same time, right? In the beginning, you may fall, but as you practice, these signals fire together repeatedly. Because they fire together again and again, their connection becomes stronger, right? After some time, your brain learns the patterns and you can ride smoothly. This is how the Hebbian learning happens in the real life. Okay, so we can just summarize this one by simply recalling the cycle example itself. Okay, so the sign of the weight between two nodes is determined by the sign of their input signals. If both nodes receive inputs that are either positive or negative, the resulting weight is strongly positive. So if one node's input is positive and while the other nodes is negative, the resulting weight is strongly negative. That's simply how a Hebbian learning rule works. So the second one is perceptron learning rule. A perceptron is the simplest type of artificial neuron used in neural networks. It takes some inputs, multiplies them with weights, adds them up, and then decides the output using a threshold. So this is how a basic perceptron works. So coming to the perceptron learning rule, this rule adjusts weights to minimize classification errors. Simply, a perceptron learning rule is an error correcting algorithm designed for single layer feed forward network that we have discussed yesterday. It is a supervised learning approach that adjusts weights based on the error calculated between the desired and the actual outputs. So here weight adjustments are being made only based upon the error present in the output. So we can take a simple real life example like a super simple one, that is if you show one image of an apple to a student and then the student recalls it to be saying as it's an orange, you can just correct it by saying, no, this one is an apple. This is how the perceptron learning rule simply works. Okay, you can just take this one as a simple example to recall this one up. So the next one is delta rule, also called as Withrow-Hoff learning rule. So it minimizes the error between the actual output and the desired output using the gradient descent. Okay, delta learning rule is a supervised learning algorithm that uses a continuous activation function, that is just like the iteration function, also known as least mean square method. It aims to minimize the errors across all training patterns. This rule is based on the gradient descent approach, which iteratively reduces error by updating the weights of the network. So here, it iteratively reduces the error by updating the weights of the network. So an example, or we can just explain it using a simple example, just like think of a glass which will consist of 200 ml of water in it. Okay. So your task is to add the glass with full of water. So you just need to add a 200 ml of water in the glass, right? So first of all, when you pour water into the glass, you are only pouring a 150 ml of water. Okay. So there is a 50 ml being left over. There is a 50 ml that's being left over here, right? So the first time there was an error of 50 ml. Next, the second time you will be understanding the error and you will try to pour it up to 200 ml itself, right? So we could understand it just like in the second time you just added it to be like 180 ml of water into it. Okay, 180 ml. So the error is being minimized. So the error here is only 20 ml, sorry, 20 ml. Right. The next time you will be pouring it with enough water. Right. This type of technique is used in delta rule. This is the simple example that we could use to explain delta rule. Here we are using gradient descent to iteratively reduce the error by updating the weights of this network. So the fourth one is correlation learning. It updates weights based on the correlation between input and output signals. Correlation learning rule is based on the principles similar to the Hebbian learning rule. Specifically, it states that if two neighboring neurons operate in the same phase at the same time, the weight between them becomes more positive. Conversely, if the neurons operate in opposite phases, the weight becomes more negative. So we can think about it like just like we learned that switching on always turns the light on, right? So the correlation learning rule means we strengthen the connection whenever input and output fire together. Okay. So, however, unlike the Hebbian rule, the correlation rule is supervised. This means it uses the target response for calculating the change in its weight. This supervised approach allows for more precise adjustments based on the desired output, improving the learning process. So this is how a correlation learning rule works. So the fifth one is competitive learning rule. The neurons compete to activate and only the winner gets updated. So here, the competitive learning rule, output nodes compete to represent the input pattern and only one node, the winner, is activated. We can learn it using a simple example. As we can see here, a competitive learning works like a classroom situation where many students try to answer the teacher's question. All students receive the same question as the input, but only the fastest will be answering it or getting the chance to answer it. That student is proclaimed as the winner here. And only the winner will be getting the feedback from the teacher. So this is how the competitive learning rule works. Here as well, in the neural networks, neurons behave exactly the same way. Many neurons compete and but only the winning neuron updates its weights here. This is why competitive learning is also called the winner takes all rule. Winner takes all So here, competition among nodes is being done. All output nodes compete to represent the input pattern. The node with the highest output is declared the winner and is assigned an output of 1, while all other nodes are assigned zeros. Here you can see there are 4 output nodes, and one of them will be proclaimed as the winner here, and it will be assigned with the value of 1, and the other will be assigned with the value of 0. Neuron activation. A subset of neurons with randomly initialized weights undergoes activation. However, only one neuron, the winner, remains active at any given time. Weight update. Only the weights of the winning neuron are updated. The weights of all other neurons remains unchanged. So this is how a competitive learning group works. We have discussed along 5 different learning groups. There are many more. So thank you for listening to me.